Sorry. Okay, so I boo-booed and forgot to hit record, so if anyone has to watch this, I'm sorry. But so far what we've done is we drew a right triangle with 3 centimeters long, and we just used our ruler, 3 centimeters and 4 centimeters, and then we measured the hypotenuse and said it was 5, so we wrote that in down here. We just drew this one, a 5, a 12, and figured out that the hypotenuse was 13. Do you guys need more time to draw this one or no? The next one? Yes? No? Okay, so now we're going to draw one that has 6 centimeters and 8 centimeters, and then we're going to figure out how long our hypotenuse is. Okay. What did you find the hypotenuse length to be? 10. Very good. So we have 6 squared, which is 36, 8 squared, which is 64, and 10 squared, which is 100. Is it feasible that we would draw out these triangles all the time? I don't want to draw these out all the time. Okay, so I want you to take a minute. How could we use the legs, the long and the short leg, to come up with my hypotenuse? How could I use this and this to come up with my hypotenuse? Talk in your group real quick. How could you do that? Add what together? What to? Okay, so what Kale is saying, add 36 and 64, and what do you get? Okay, if I add 25 and 144, what do you get? 9 and 16. 25. But it's the squared answer. It's not, you're not adding the legs. A lot of people will say, well, the leg 1 plus leg 2, so 6 plus 8, but that doesn't give you 10. So it has to be the answer. And I'm going to show you what that's going to look like. So, I don't want to draw this next one out. What's 8 squared? 64. What's 15 squared? You got a calculator, type it in. 15 squared. To what? 225. So, what's my answer going to be over here then? 289. But I want to know the x. How would I figure that out? How do you get rid of a square? How do you get rid of a square? Square root. So we're going to take the square root of 289. What is the square root of 289? 17. This is called, go ahead and flip the page over. We're going to write it right up here. This is called the Pythagorean Theorem. A squared plus B squared equals C squared. C always has to be your biggest number. Always. Has to be your biggest number. Always, 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 always. A and B don't matter. If it's A is bigger or B is bigger, that doesn't matter. But C always has to be your biggest number. Does that make sense? I would make sure I have all that written down because you are going to use it in absolutely every content objective in this unit. And like I said, I'm teaching 2 content objectives today. Okay, we're going to go ahead and switch gears to the paper I just gave you. Okay. Okay, let's get started. I can use a Pythagorean theorem to find missing side lengths in a right triangle. What's up? Go quick. Most of this we've already talked about. Hypotenuse, we said that's my longest side. The way I remember it too is that 90-degree angle, if you kind of make an arrow, it'll always point at C. Then our legs A and B, doesn't matter which one's which. And then when we put it all together, it's called the Pythagorean theorem. Okay? You will use the Pythagorean theorem in your life a lot. Like, construction work uses them probably daily. All right. Let's get started. Find the length of the hypotenuse. We know the hypotenuse is C. In a right triangle with leg lengths of 9 and 12. Does it matter if I put 9 in for A or B or 12 in for A or B? That part doesn't matter. I tend to go smallest to biggest. So I tend to do 9 squared plus 12 squared, and I'm looking for C squared. What's 9 squared? 81. What's 12 squared? 144. So what I need to do now is I need to add these together. So take your calculator, add 81 and 144 together. This is not our answer. How do you get rid of a square? Square root. C equals 15. You'll see why later, because I'm not going to be this nice all the time. Okay, you're going to try one like that. It says, find the length of the hypotenuse. We know hypotenuse is C. And a right triangle with leg lengths of 5 and 12. Does it matter where 5 goes in A or B? No. Does it matter where 12 goes? No. Okay, but we know we're looking for C.
Do you have to check on any of this, Janet?
Some, not much. Okay, so 5 squared plus 12 squared. What's 5 squared?
25.
And 12 squared.
144.
So we're adding these two together. When we add these two together, what is it that you get?
169.
Equals C squared. And the final step is I'm going to do what? Square root. Do you see why we balanced first? We did equations first? Because you're going to need it in every unit I teach. Okay. Now, this is pretty easy, right? Not too complicated. I'm not making it more difficult yet, I promise. But we are going to talk about real life situations. Because sometimes it's not going to work out to a perfect square like that where it just comes out to, 13. This one, a baseball diamond is a square, which is true. A baseball regulations require that the bases have to be 90 feet between them. So from home plate to first base is 90 feet. First base to second base is 90 feet. What's the shortest distance between home plate and second base? Round to the nearest foot. So we have 90 squared plus 90 squared, and I'm looking for that shortest distance. Okay. What is 90 squared?
8,160.
So I have that twice.
16,000.
So now I'm going to add these two together.
16,000.
And now this is, don't say the answer yet. I want everyone to grab the calculator and take your square root of this. Don't say the answer yet. Did you get a decimal?
Yes.
Yes, and it's telling us to round to the nearest foot. Did you get 127.27? So this is the nearest foot. The 2 makes the 7 do what? Stay the same or go up? Stay the same. So we're going to say this is 127 feet between home plate and second base. All right. Do you guys know how they measure TVs? If I have a 50-inch TV, though, where's that 50 inches come from? It actually comes from, so if this is my TV, it actually comes from the diagonal right here. That's how they measure TVs. So a square television screen has sides that are 23 inches. So if it's square, I know that this side's 23 and this side's 23. Find the approximate length of its diagonal to the nearest tenth of an inch. So I'm looking for that right there. I want you guys to try and find that. What's 23 squared? So now I'm going to add these two together. And I want everyone again, don't say the answer out loud, do your square root.
So if it's a 5, do I round down?
No, you're supposed to go to that place value. So it should be number, decimal, and then another number, because we're rounding to the nearest tenths. And that is the tenths place value, where your 5 is. What's behind the 5? That's what I need to know. 2. So the 2's tell the 5 to stay the same. 0.5. All right, so we get this, right? Do you agree? It said round to the nearest tenths. This is the tenths place value. So we look at the number behind it. The 2 tells the 5 to do what? Stay the same, so 32.5 inches. So this would be a 33-inch TV. Okay. Now I'm going to mix it up a little bit for Anya. It's not always going to be really nice where you're always missing C. Sometimes you might be missing A or B. Since it doesn't matter which one's A and which one's B, right? But we know there's our right angle, always points at C. So C is 14 squared. I'm looking for A or B. It doesn't matter. I tend to always leave it as A. All right, so we're going to do this. A squared plus, what's 12 squared?
144.
What's 14 squared? 196. Using your knowledge of last unit, what should I do? Say it louder, what? Minus 144. Whatever I do to one side, I have to do to the other. Opposites cancel. Do you agree with me? Okay, grab that calculator. Type in the square root of 52. What do you get? So I got a decimal, right? This is not a story problem where it tells me to round in inches so I can make sense. So when we do this and it comes out to a decimal, we're going to break it up into our tree. So I'm going to break this up. 52 can be 26 and 2. And 26 can be 13 and 2. Can I break any of those up anymore? No. So we write it in order. 2 times 2 times 13. What am I looking for? This was CO6. Pairs, yep. So my pairs, they come out front. Whatever's left goes on the inside. Yes, dear. I'd go quick because I'm going to do CO3 here in just a minute. All right. I want you guys to try this. Notice, look, it's pointing at C. So do I have C? Yes.
Do you get the positive, negative stuff?
Yes, it's good to know that it's still a positive, negative, but usually on this you won't see that as often because you're not going to have a negative side length. You see what I'm saying? Okay. All right. So we have C, right? So what am I missing? A or B? Does it matter which one? It doesn't matter. I always leave it as A. I don't know why. So we're looking for A squared. We have B squared. We know we have C squared. And I just wrote C instead of squared. So you find me the side length, please. We don't do decimal, remember? We do the tree. Do you agree with me? What I wrote? Yes? What is it that I should do next? What should I do? Minus 64. Whatever I do to one side, I do to the other. You guys agree? 57? Take the square root. It comes up to a decimal, correct? The only way to break up 57 is 3 and 19. Can I break up 3 anymore? Can I break up 19 anymore? When that happens, your answer just remains the square root of 57. You just leave it then. That is much more of a precise answer than writing it's almost 7.2. Leaving it the square root of 57 is much more of a precise answer. And the reason we do it this way is this is exactly how you will see it on ISASP. They don't do decimals. They do radicals. That's what these are called, or radicals. Okay. At the top of the next page, you're going to see a thing that says the converse of the Pythagorean Theorem. I would like you to write CO2 right above that. You'll usually hear this called the Pythagorean Theorem converse. What that means is what we were just doing, the Pythagorean Theorem, a squared plus b squared equals c squared, only works in right triangles. It doesn't work in an isosceles triangle. It doesn't work in a scalene triangle. It only works in right triangles. So, down here, they're telling us all our side lengths. We just have to put them in. A is 4 squared, B is 9 squared, and C is 10 squared. So we're just putting it in. What is 4 squared? What's 4 squared? 16. What's 9 squared? And what's 10 squared? Okay. So what do you think we should do with these two? Add them. When I add them together, I get 97. Does 97 equal 100? That is not true. So this is not a right triangle. Now, if they would have matched, what would that have meant? It is a right triangle. The Pythagorean theorem only works in right triangles. So this could this still make a triangle? Absolutely. But does it make a right triangle? No. Okay. Stop, you two. All right. On the back. This is your last problem. A triangle has side lengths of 3.5, 12.5, and 12. Determine if it's a right triangle by using the Pythagorean theorem. Make sure to put your numbers in the appropriate spots. What two numbers should go in for A and B?
3.5.
Very good. Does it matter the order? I'm glad you noticed 12.5. It's the biggest, right? So it has to be C. What is 3.5 squared? 12.25?
Yeah.
Plus 12 squared is 144. What's 12.5 squared?
156.25.
So now I add these two together, right? And what do you get? 156.25. What do you notice? They're the same thing on both sides. So what can we say about these measures? It's a right triangle. We have done both CO1 and CO2. Okay? Tomorrow,